We'll take you through how to do a univariate analysis in SPSS. Here I am playing with my own data set here. This is a data set of 400 adolescents admitted into psychiatric hospitalization inpatient, and they all took the crisis stabilization scale. The crisis stabilization scale is a 25-item measure, and it has two subscales, a coping subscale and a commitment to follow-up subscale. The coping subscale is the only one we're going to be playing with right now. Notice that each item is evaluated on a -2 to +2 scale. So the lowest, if the first 18 items consist of the coping scale. And so the lowest value that somebody can get is a -36. And the highest value that somebody can get is a +36. So all the scores from these adolescents, if an adolescent was to get -2 on every item for the first 18 items, that would be a -36. And if they were to get a +2, that would be a +36 on every item. So here are the 400 scores for the adolescents. And in order to do a univariate analysis here, what we do is we click on Analyze, we click on Descriptive Statistics, and we click on Explore. And what I'm going to do is I'm going to click on this coping scale here. I've got a lot of variables here, but I'm going to click on Find Coping and click on that there and move it to the Dependent List. And then I'm going to click on Statistics, and I like what I have here. I'm just going to get my descriptives here. And I'm going to also click on Plots. I don't really care about the stem and leaf plot. We'll take a look at the histogram, and then I'm going to take a look at the normality plots with tests. Then I hit Continue, and I click on OK. Now I get my 5-number summary data here, my minimum and maximum values, my interquartile range. I can see my mean of 6, about 6.01, and my standard deviation of 12.73. I can see that this is a kind of looks like a fairly normal distribution. Kind of hard to tell from the histogram. Remember in your, when the author, Dimitrov, talked about the QQ plot, the more the data adheres to the diagonal line, the more normal it is. So this is a pretty normal looking distribution here, as you can see. It stays pretty close to that line. It even peaks a little bit right here in the middle. You don't really need to worry too much about this table here. I can sometimes click on it and just hit click here and just cut it out, so that doesn't disturb me. You can see the median is slightly from the center. This would be the first quartile, the 25th percentile, the 50th percentile, and the 75th percentile. It's slightly negatively skewed. Not a lot, but a little bit. And again, it's a fairly normal distribution. And so this is how we get a distribution or do a univariate analysis. We can get information on the skewness, slightly skewed, and we can also look at the minimum and maximum values, the range of values, and notice that the high score was 34 and the lowest score was -28. So we had a range of 62. We can basically get a good idea of the distribution here, and a little bit of information about our teens who took this measure. Now, if I want to create standard scores, because sometimes messing with negative numbers like a negative 28 and a positive 34, that can be confusing and it's difficult to explain to people. And so if I just want to create standard scores here off the coping scale, I can go to Analyze, and I can go to Descriptive Statistics, and I click on Descriptives here. And all I do is I move my variable, my coping variable, over, and I say Save Standardized Values. This is going to take my coping value and compute it into a z-score, a standard score. It's going to express the score in standard deviation units. So notice when I do that now, I have a new value called z-coping, and everything has been converted to a z-score. If I want to look at the descriptive statistics related to that z-score, I can still I can run that. I can go to Analyze Descriptives, and instead of looking at coping, I'm now going to look at z-coping. And here I can see that I got a mean of 0 and a standard deviation of 1. Everything has been converted to a standard score. Now, sometimes, still, if I say, okay, I'm negative 1.7 standard deviation units below the mean, or I'm 0.63 standard deviations above the mean, that doesn't make a lot of sense to people either. It's sometimes easiest to convert that 0 being the mean. So that 0, that's the mean now, that was a 6.01. Now I'm going to convert that 0 mean to a 50. So I can just put it all on a standard score. And the way I do that is I create a t-score. Let me clear this here because I didn't want to run that. And what I'm going to do here is I'm going to say, go to transform, and I'm going to compute a variable. And I'm going to compute t coping. That's what I'm going to call it, because it's going to be a t-score. And it's simply 50 plus 10 times the z-score. So how do I do that? I take my z-score. I indicate that I'm going to multiply it by 10. And then I'm going to add 50. And it's going to follow order of operations. It's going to multiply my z-score times 10 and then add 50 to it. And that's going to make all my z-scores into t-scores. Everything's going to be positive now. And I have a mean of 50 and a standard deviation of 10. So that mean of 50 is going to become, is going to be equal to the mean of the z-score mean of 0 and the raw score mean of 6.01. And you can see that here. So now everything has a mean of 50 and a standard deviation of 10, and I have all positive values when I go to Analyze, and I go to Descriptives, and I click on, let's just click on all these scores here. Let's click on coping, so you can see them all together, z-coping and t-coping. And I can go to options, and I can say, yeah, we got our mean and our standard deviation and minimum and maximum values. So notice what we have here. I have a mean of 6.01, a z-score mean of 0, and a t-score mean of 50. So everything is equal here. And the distributions will all look the same. So I hope that helps in explaining how to do assignment 3. And certainly if you have any questions, feel free to interact with me. Interaction is crucial. Hey, hope this was helpful.